The observable universe contains over 2 trillion galaxies, yet despite that staggering number, our perception remains trapped within a narrow bubble of visible light. Looking at a galaxy called Alcyoneus through a standard optical telescope reveals very little. To our eyes, it appears as a tiny, unremarkable speck of light floating in the darkness. But the universe communicates its largest structures through frequencies we cannot see, specifically low-frequency radio waves. Relying on visible light alone leaves us blind to the true scale of the cosmos. To see the full picture, astronomers had to build an entirely new type of eye. That eye is the LOFAR network. Instead of a traditional physical tube, LOFAR is a massive virtual sensor made of thousands of small antennas spread across Europe, working together to capture those elusive radio signals. In 2022, researchers processing LOFAR data encountered a structure measuring 16.3 million light-years across. For perspective, it's 160 times larger than our Milky Way. This scale was so vast, the team assumed they were looking at a data processing glitch. Scientists rechecked the math multiple times, running the data through separate verification processes. Every test confirmed the same result. The anomaly was a real structure 3 billion light-years away. By verifying the data, the team identified the largest galactic structure ever recorded. Now they had to determine what kind of engine could produce a footprint of that magnitude. Our Milky Way is a spiral galaxy, defined by this flat, rotating band of stars. Alcyoneus is different. It is a giant elliptical galaxy, a vast, formless swarm of older stars. At its core sits an ultra-massive black hole. It contains roughly 400 billion times the mass of our Sun. This black hole pulls in gas and dust, creating a rapidly spinning accretion disk. Friction within this disk generates intense heat, reaching millions of degrees. This thermal energy blasts material away from the black hole's poles at nearly the speed of light, forming what astronomers call relativistic jets. As these jets collide with the surrounding space, they balloon outward. This creates the massive radio lobes that the LOFAR antennas finally detected. The record-breaking size of Alcyoneus is defined by this violent radio footprint, stretching far beyond the reach of its actual stars. This raises a physical mystery. Other galaxies have black holes just as powerful, yet their jets never reach this scale. Why did Alcyoneus grow so much larger? The answer involves the intergalactic medium, the sparse gas and matter that exists between galaxies. Alcyoneus occupies a rare cosmic region where the intergalactic medium is exceptionally thin. Without dense gas to provide friction, the jets encountered an open highway. They traveled unhindered for billions of years, reaching a length of over 16 million light-years. Alcyoneus is the product of a monster engine placed in a frictionless environment, allowing it to bypass the growth limits seen in most other galaxies. This discovery created an immediate conflict with our established cosmological models. Alcyoneus represents a scale of structure that our current maps of the early universe simply did not account for. Modern computer simulations of galactic growth failed to predict that a radio galaxy could ever become this massive. This suggests there are variables in the life cycle of a galaxy that we are only beginning to identify. If a structure this large was effectively invisible to us for decades, it suggests that other giants may be hidden in data we have already collected. To find them, astronomers are deploying artificial intelligence to scan the massive archives of LOFAR data. These algorithms can identify structural patterns in the radio sky that are too faint for human eyes to recognize. Looking at these dishes, we see the next step in this journey. This is a component of the Square Kilometer Array, an upcoming radio telescope that will provide the sensitivity needed to map even more distant and diffuse structures. Astronomers expect Alcyoneus to be the first of many such discoveries. Now that we have the technology to identify them, we may find that these giants populate the unmapped corners of the cosmos. Every time we build a better tool to look deeper, the universe proves to be larger and more complex than our previous models predicted.